Good morning to all of you. Welcome, you guys. Welcome you all. We are live. Hmm. First of all, do check करके बोलिए now. Is the audio videos clear to everybody? Very good morning to all of you. So you can start your serious preparation with an academy. So 180 days of your preparation can change your complete rank and your career also. So this is and join the last live batch. And there is a great news to all the aspirants. Now this an academy subscription that is just 7,999 only. इसके साथ you will get additionally one but benefit भी आपको मिलेगा. And so this iconic के लिए 10,999 rupees to enroll for it. You can use the code BV Reddy and to have a great learning experience from the top educators team. Do enroll immediately. We are starting a last live batch which is commencing from the 24th. So shuru ho gaya. So then start your serious preparation with the an academy. So you can see now here. So these are the top educators team. आपको एक साथ मिलेगा. They will provide you the best knowledge. This is the last live batch. And from yes 24th onwards हमने नया बैच शुरू किया. You can have a look at now. So control systems and networks is starting. 28 के लिए भी नया बैच 24 से शुरू हो गया. Control systems and networks are started. And so MahaSangramam, so for GATE 2027 के लिए, so test series for electronics engineering that is just 1,499 rupees only. And you can use the code of BV Reddy and to join. Totally how many tests you can see now? 73 tests, and the test which is computer based test, and so it is curated by the top educators. You can see now an academic GATE 2026 ka rankers. You can have a look at ESC 2025 ka rankers. And what we offer now, you can see now the top educators classes milega, and live doubts, evaluated test series, and structured courses, PDF, live test, unlimited access. आइकॉनिक में एडिशनली आपको क्या चीज मिलेगा? फिजिकल नोट्स मिलेगा एंड 1-to-1 गाइडेंस भी आपको मिलेगा. You can book your time slot according to your time convenience and interact with your mentor. Let's crack it. Right. And so this is the 6th class in this series. We have completed the 100 most expected questions and the previous year SSC, JEE, AE, AEE, all type of questions we have discussed in the previous classes. Yeah, this is the 6th class. The student who has missed, so those can able to utilize these opportunities. Okay, utilize this thing. Chalo, let's start doing one by one problems. The current drawn by a tungsten filament lamp is measured by an ammeter. The ammeter reading under steady state condition will be dash the ammeter reading when the supply is switched on. What happened? You tell me. Measured by a ammeter. So this is what happens now. So the current drawn by a tungsten filament lamp measured by an ammeter. The ammeter reading under steady state condition will be dash the ammeter reading when the supply is switched on. Tell me now here. Whose current is more? You tell me now. Whose current is more in the steady state current and immediately switched on mean that is a transient state. And whose current is more? You tell me now here in steady state current and transient state. Transient state current is more. At transient state, more current, more current, more current are drawn. So that's why what should be now here? Transient state current is more compared to the steady state currents. Okay. Transient state we have the more currents are there. Next one. Tesla is same as. What the Tesla is basically, Tesla is a unit of the magnetic flux density. Tesla is a unit for magnetic flux density. Magnetic flux density, other unit is Weber per meter square, and that is taken as what? Tell me now. Tesla. Weber per meter square, that is also taken as what? You tell me now. Tesla. So that means what's option you can see now? Option B. Next one. Equivalent resistance of the circuit is. Now find the equivalent resistance now. So first of all, you can see now how these two resistors are connected. You see this thing? These two are connected in series, so that is 6. Next, and these two are connected. How these two connected? You tell me now here, which is equal to 2. And 2 and 2 are again series will become 4. 4 and 6 are parallel. 4 and 6 are parallel. 4 into 6 by 4 plus 6, which is 10. So this value will come to be a 2.4. So then what is the R equivalent now? Which will be equal to 4 plus, we can say 2.4 plus 8. Then how much this value? Tell me now here. This is 14 now. 14.4. So that is first option. Next one. SI unit of conductivity is. What is the conductivity means? What? Conductivity is nothing but a reciprocal of resistivity. Conductivity will denote as sigma, which is equal to what? Tell me now. 1 by resistivity. 1 by resistivity. Resistivity means what? You tell me now. That is rho. So that means conductivity units. which will come to be a 1 by resistivity na. Resistivity units are ohm into meter. So this is ohm into meter. So that's why sigma value will come to be what you can see now here, which will be ohm inverse. That means mho per meter. Mho per meter. So what's the option? You can see now option D. Next one. Calculate the voltage drop across 14.5 ohm resistor. Voltage drop we need to get. So that means they ask you to find the voltage here now. If I call this voltage is V1, so we can use a voltage division. So this voltage division, which will be equal to what? Tell me now. 14.5 by, tell me now, 14.5 plus 25.5 plus 60 into 200. Now simplify it. Now how much will come it as? 14.5 by, this is how much will get now? 15 and 25, 40. This is 100. 100 into 200. Now simplify it. So 0 zeros now here. Now that means 14.5 into 2. So it will be equal to 29 now. So that is option C. Next one. Find RAB of the circuit shown below. Equivalent resistance. Check for the balancing of a bridge here. First of all, whenever you can find this type of shape, so immediately do check for the balancing condition of bridge. Is it balanced or not? That is R1 by R2, and which is equal to what? Tell me now. This R3 by R4. That is R3 by R4. So satisfy now. So that means we can say that bridge is balanced. So this is a balanced bridge. And if the bridge is balanced, then see what will happen now. So we can say now current to the diagonal element is 0. So this element current is 0 now. So we can remove this element completely from the network. Now, so then how we can redraw the circuit now here? A 20 and this is 30 and this is 10 and this is 15. So now you can see now here these connections. So these two are in series and these two also in series. So how much this value you can see now? Right, so this value which is a 30 ohms and this is what you tell me now, 45 ohms now. Now thereafter these two are in parallel, so that means RAB, which will come to be what? Tell me now, 30 into 45 by 30 plus 45. So how much will come? 75 now. So how much this value which will be given us? How much now? 18 ohms. So first option. Next one. For the linear circuit shown in figure, when R is infinity, V value 20. Where is V? Might be here. Okay. Next, when R is 0, I is equal to 4. When R is 5, they ask him to find what is the value of current. So when R is infinity, so they given R is infinity, they given the voltage, given this voltage is nothing but open circuit voltage now. That open circuit voltage which is given as 20 volts. And as we know, this open circuit voltage which is nothing but VTH. And when R is 0 and we have the current, this current is the short circuit current. How much this value, which is nothing but 4 amperes. Now we know the VTH and ISC. From this we can get the RTH value. RTH, which will be equal to what we can say now, VTH by ISC, and which will come to be what, tell me now, 20 by 4, and which will be equal to what we can say now, this is 5 ohm. RTH value 5. Now they are asking to find when R is 5. So after getting the VTH, RTH, the complete circuit we can replace as a Thevenin equivalent से replace करो. We'll replace this as a Thevenin's equivalent ना VTH and RTH calculations होने के बाद. So this is VTH and this is RTH. And here we have connected the load, we have connected now. This value R value given as a 5, and this value also we got it as 5 only. How much the VTH we got, which we got it as a 20. Now we need this current, we need now here. So how much this value of IU, tell me now, this is 20 by 10, which will be equal to 2 amperes. Done. Next one. The current I in the circuit shown in the figure is the current they are asking to find. Yeah, you can tell me now. Let's try to write the nodal equations. So if we say this voltage, which will be a V1, and this voltage is V2. Now this 2 is an entry current and 4 is also entry current, and which is equal to what we have told now, V1 by 2 plus what we can say, this is V1 minus V2 by 2. Okay. Now from this we'll get the 6, which is equal to V1 by 2 plus V1 by 2 means V1 minus this is what we have told now, V2 by 2. That is equation 1. Next one. So from at the V2 node, so here 4 is a leaving current. Yes, plus V2 minus V1 by 2 plus V2 by 8, and which is entry current, which will be equal to 7. Now we have minus V1 by 2 plus V2 by 2 plus V2 by 8, and which will be equal to 3. Okay. So thereafter we can simplify the two equations and two unknowns. We need to get V1, V2 values. From the V1, V2, we can get the value of current. So get the value of current. V1, V2 values. How much you tell me now here? If I so this is minus. We will bring these equations. Now we can say this as minus V1 by 2 plus what will be now 8 is LCM. So 4 plus 1, 5. 5 V2 by 8, and which is equal to 3. And this is the second equation. Fine. So what we can do here, if I multiply the first equation with the 1 by 2, will cancel now here. So we have this as minus V1 by 2 plus 5V2 by 8, and which is equal to 3. Next, if we multiply this is V1 by 2 minus V2 by 4, and which will be equal to what you tell me now, 3. If I add these two equations, V1 by 2 will get cancelled. So we can get it as what tell me now, V2 we have taken common, that is 5 by 8, 5 by 8 minus 1 by 4 is a else term will come, so which is equal to 6. Yeah, you can see now here this is V2 into what tell me now, 5 minus 2, that is 3. So that is 3 by 8, and which is equal to 6 now. 3, this is 2. Now will come the V2 value which is equal to 16. V2 16. From this we can get the V1 value. How much will get the V1 now here? 6 minus V6 equal to V1 minus 8. So V1 value which is equal to 14. So from this we need to get this current I value. How much this value of I you tell me now? I which will be equal to V1 minus V2. V1 minus V2 by 2. That means I1 value 14 minus 16, that is minus 1. So that is minus 1 amperes. Got it? And then next one. The material to be used in the manufacture of a standard resistance should be of. The material should have what tell me? It has a high resistivity and low temperature coefficient. The material what we are using for manufacturing of resistance, it should have high resistivity high, and that means it should be capable to handle the high powers, and as well as what tell me, low temperature coefficient. That means it should not change with the temperature. Temperature variation should not affect. It should have a high resistivity and low temperature coefficient. Next one, a 200 watts 20 volts bulb and 100 watts 20 volt 200 volts bulb are connected in series and the voltage of 400 volts is applied across the series combination. In this case, what happens? You see this thing here. Now, if I call this as the first bulb, this resistance R1, this resistance R2. Basically, the resistance which is given as what, tell me now, V square by P. The resistance is given by V square by P, so that is resistance which is directly proportional to 1 by P. And which has a high power, you see, voltage same na high power. So we can say this as P1 greater than P2. That's why we can say R1 is less than R2. Is this point fine? This thing is clear? Next. Next, what else we need to see it now here? R1 is less than R2. So now you see this thing. How the connection of resistors, you tell me now series connection. In series connection, current is same, and which I can say this as what, tell me now, I squared into R. Current is same, so that means power which is directly proportional to resistance now. So that means which bulb has a more power, you can see now here P2 having more power compared to P1. So that means which will have 200 watt bulb will be brighter than, so the 100 watt bulb is brighter than 200 watt bulb. Okay. Next one. In the network shown, if one of the 4 ohm resistances is disconnected when the circuit is active, the current flowing now will be, yes, 4 ohm resistor is disconnected. In this case, what will happen to the current, they are asking here. So you tell me now here, when this one of the 4 ohm is disconnected. So here, when the 4 ohm resistor is present, when 4 ohm is present, so that means, yes, now let us say these two parallel will become 2. That means I value will becomes what you tell me now 24 by what I now 6 plus this is 2 plus 2, which will come to be a 2.4 amperes of current. When the 4 ohm is disconnected and this is removed, if I remove this thing, the resistance will become 12. Now this, if I say I1, second case I2 equal to when the 4 ohm resistor is disconnected. When 4 ohm resistor is removed. When I remove this thing here, in this case, we can say this current I2 and which is equal to 24 by now 6 plus 4 plus 2. Now this is 12, 24 by 12 now. So in this case, we have 2 amperes. Now what happens now here? I2 is less than I1 now. So the current is decreases. Due to this, current is decreases. Understood? Hmm. Done. Next one. For the circuit shown, Vs is equal to 5, I is equal to 3. When Vs is equal to 200, what will be the value of I is? This is SPT concept. So you need to recollect the concept of SPT. Good problem. So then when Vs is equal to 0, they given this current. According to SPT, what we do here? So at a time, we'll consider network should contain only one source, isn't it? So first case, we have deactivated the Vs. In this case, what we have, tell me now? Now, when Vs is equal to 0, so we have deactivated, that means we have only one source is present. We have only one source is present. And this is deactivated. So this is 10, and this is 20, and this is 30. And this only Is is present. In this case, we have a current. So this current which will be given as I1. So that I1 current which is given as, what you tell me now, 3 amperes is given. Now we'll consider the Is we are considering here. So Vs we are considering now here. Now Vs we consider now here. The other source we should deactivate. What the other source now? Current source now. Now the current source we should deactivate, and we need to deactivate the current source by consider voltage source. Okay, they given this is negative, this is positive, they given. And the current source is deactivated means open circuited. Right, so this is 20 and this is 30 and this value is 20. Now we need this current now here. This current is I2. How much the Vs value given now? 200 volts they given. So we can simplify this thing. Find the value of current I2. What will be the I2 now here? It will move in opposite direction. So this I2 value which is equal to minus 200 by 500. So then this value which will come to be what, tell me now? Minus 2 by 5. That means what we can say, minus 0.4. This 50 now, sorry. This is 50 in a denominator. That means this value what we can say now, minus 8 amps. Now we need what, tell me now here, when both are present we need now the total current. It should be given as what we can say, that is I1 plus I2. So this is I1 is equal to 3, I2 is minus 8 now. So which we are getting it as minus 5 we are getting here, but no option. We got the 5 we got, but there's no option at all. कोई गलत किया क्या हमने? Hmm? 50, yeah. Sorry. So 50, this if we multiply, this is what you tell me now, -4. Now we wrote -8, we wrote, isn't it? So this is -4, that means this will be -1. So option B. Yes, correct. Next one. The unit of resistivity. Hmm. The unit of resistivity. Resistivity units. Resistivity, that is rho, which will be given as ohm into meter. Ohm into meter. This is the resistivity. Now see the options now. Hmm. Option A and B will give the same only, na? Okay. The unit of volume resistivity. Hmm. Volume resistivity, not resistivity. Volume resistivity they ask to find. Unit of volume resistivity. Volume resistivity. Mhm. Okay. The resistivity unit is this much. Okay. Volume resistivity. Remember. Volume resistivity unit. This is what you tell me now here. This is ohm into meter cube by meter square. Ohm into meter cube by meter square. Okay. Next one. Four resistances are connected in parallel. Their combined resistance is equivalent resistance they ask to find. These four are connected in parallel. So we'll do 2, 2. We can do it now. First, all these are connected in parallel. So instead of analyzing all the resistors at a time, we'll analyze 2, 2. We will analyze this. So this is 2 ohms and this is 4 and this is 5 and this is 20. Now first I will do these two. I will do. So these two is what I will now 2 into 4 by 2 plus 4 now, which is equal to 6. 2, this is 3, which will come to be what I will now 4 by 3. Next these two parallel, and which will come it as 5 into 20 by 5 plus 20, which is equal to 25. 5 fives, this is 5 fours. So will come to be a 4. Now simplify this thing. Now these two are again parallel. So this means what is the equivalent, you tell me now here. 4 by 3 into 4 by 3 plus 4. So tell me how much will come. This is 16. Okay, 4 into 4, 16 by 3 by what will get you? Tell me now here. This is 4, 4 plus 12 by 3. This value will come to be a 16 by 16. So which is 1 we are getting here? Check it. Is it 1? Option A. Next one. The bigger the value of R is, the value of R they are saying here. Now, so here first you can see now how these two are connected. These two are connected in parallel. So this value which is equal to 5 ohms. Okay, 5. Now this is 10. So you can see now here the equivalent, this current is given now. This current is given as 8 amperes. So here, then how much this voltage? Tell me now. This is the 40. So then what about this voltage? You see this thing here. So then this is 60. So that means R is equal to what we have. Tell me now here. Voltage by current only now. And that is given by 60 by 8. So how much this value now here? 4 2s 415, and which will be equal to 7.5 ohms. Right. Next one. Yeah, you can try this one also. Yes, now try this one. What will come? Power consumed. So first find the equivalent resistance of this whole combination. Equivalent resistance of this whole combination. 30, 20, these two are parallel. Will becomes what? Tell me now. 20 into 30 by 20 plus 30, which is equal to 50. Now tell me. 50 plus 8. See this now. So how much will come here? 5. This is fourths. 12, 20. So that means equivalent resistance, which we got it as a 20 ohms. Now we need to get what? Tell me now here. Power we need to find. So this power P, which is equal to, we have V square by R. DC power only now. So this is 100 by R. R is equal to 20. So which will be equal to what we can get now here? 5 watts. Next one. The algebraic sum of voltages in any closed path of a network equal to 0. This is nothing but what element of KVL now. What is the KVL is a? The algebraic sum of voltages in any closed path is equal to 0. That is a KVL. Next, specific resistance of material is measured. Specific resistance means resistivity. Resistivity units are what I mean, ohm into meter. Resistivity, specific resistance is nothing but resistivity. Resistivity. Resistivity rho. So units are what we can see now here. Ohm into meter. Ohm into meter. Next, phase angle between inductor current and the applied voltage. Inductor current lags the voltage by 90 degrees. Inductor, inductor current, inductor current, inductor current lags the voltage by 90 degrees. Voltage by 90 degrees. Inductor is called as a lagging element. Inductor is a lagging power factor. Next, a 10 ampere source is connected across the two parallel resistors of 3 ohms and 2 ohms. Now these two are connected in parallelly. 2 and 3 ohms. So now they ask him to find the current in which resistor, and this current is given as a 10 amperes. And this they are calling it as what you tell me now, I1. So what will be the current I1? You see this thing here. In this branch current we need now, we should take opposite resistance, that is 3 by what we can say now 2 plus 3 into 10. So how much will come here? This is 3 by 5 into 10. 5, this is 2. So which will be equal to 6 amperes. Next one. A dielectric medium is said to be linear. When we can say dielectric medium is said to be linear, so permittivity is same everywhere. Then we can say homogeneous. The relative permittivity is same in all the directions. Permittivity is a linear function of electric force. Yes, permittivity is a linear function of electric force. No, sorry. Permittivity is independent of force. Then only we can say it is a linear. Permittivity must be independent of the permittivity must be independent. Then only we can call it as a linear. Okay. Next one. By saying that electrostatic field is conservative, we do not mean that electrostatic force is conservative means this EMFT na, they combined EMFT quotient. So del cross E, which is equal to 0. It's currently 0. Yes, but they are asking not, they are saying this is its circulation 0. The potential difference between any 2 points is 0. Yes, the potential difference any point 0. It is gradient of a scalar potential. Potential difference. It is We do not mean that it is a gradient of a scalar potential. Potential difference between any 2 points is 0. Del cross E is equal to 0. Yes. Potential difference 0 from that only. No, this is not the meaning of it. Potential difference is non-zero. So this is C is not correct. It is gradient of a scalar function. Yes. If the curl of any vector is 0, then that vector we can express it as gradient of some other scalar function. That is E is equal to minus del V. Yes. Next one. Dash is a unit of magnetic charge. Magnetic charge means IDL. IDL is called as a magnetic charge. IDL is called as a magnetic charge. This is called it as what? Tell me, magnetic charge. Magnetic charge means I into DL. Keep in mind. Magnetic charge, and this is called as a source of magnetic field. Source of magnetic field. Source of magnetic field, and this is a vector quantity, and the units of this is what? Tell me now. Ampere into meter. Magnetic charge units are ampere into meter. Next, as per the concept of analogy between electric and magnetic circuits, dash is the analogy pair. Which are the analogy pairs? Conductivity. Which are the analogy pair? Conductivity, permeability. Yes, conductivity is analogy to the permeability. The resistance of a material which is given as what? Tell me now. L by sigma A. Similar to that, magnetic resistance reluctance which is given as L by mu A. So conductivity analogous to this is permeability. Next one. Dash is a unit of electric dipole moment. Electric dipole moment which is given as electric dipole moment. Electric dipole moment, and which is given as P, which is equal to charge into distance between the two charges. So the unit is what we can say now, coulomb into meter. Coulombs into meter. Next, if the electrical susceptibility of a particular material is wide, then it's okay. So this is relative permeability, permittivity. Relative permittivity is relative permittivity, that is epsilon r which is equal to 1 plus chi, that is called susceptibility. The given susceptibility is y, they ask him to find, which is equal to what? Tell me now. This is epsilon r which is equal to 1 plus y, that is 1 plus y. Next one. Dash relate the surface integral of the curl of a vector A over to the open surface enclosed by a given surface. That is a Stokes theorem. Yes, Stokes theorem. By using Stokes theorem, what we can do? Closed line integral is converted to a open surface integral, and which will be equal to open surface integral of what? Tell me now. Del cross A. Del cross A dot ds. Closed line integral is converted to a open surface integral. This is by using Stokes theorem. Okay. Next, electric field lines are electric field lines. How the electric field lines are? Either straight or smooth curved lines. Magnetic field lines are closed lines. Electric lines. How the electric lines will originate from the positive charge and terminate on the surface of a negative charge. Electric lines originate from the positive charge and terminate on the surface of the negative charge, right? That's why electric lines. Next one. See this one here. What they given now? A battery consists of n series connected cells, while the voltage of each cell is V volts and capacity is K. The voltage and capacity of the battery is, okay. So a battery consists of n series connected cells. N series connected cells, voltage of all this thing. How they connected? Series connection. In series connection, capacity is K. So that means n cells we have connected, not the capacitance. Capacity is different. That is a current. Capacity is in the sense current. So it will be n cells are connected. The overall voltage, which will come to be a, what? Tell me now here, n into V. So this is EMF, which will be n into V, and capacitance value is what? I know, K only. So option A. N cells are connected. Now current is same current is there, voltage will be added, right? Next one, for a PV cell, so they given that V naught is the open circuit voltage, IS is the short circuit current, okay. Now V is the load voltage, I is the load current at maximum power, okay. At maximum power, what will happen? At maximum power, at maximum power, what will happens now? Load voltage obviously less than the open circuit voltage. Load current So obviously, so what happens at MPT? So open circuit voltage Thevenin's voltage and Thevenin circuit. This V0 is the Thevenin's voltage and short circuit. So this is RTH, and here this is the load we have connected. Now you can see now the load voltage we are calling it as a V0. V value is a load voltage and I is the load current. I is a load current. Hmm. So how much this hmm, how much this V value? So this V value obviously less than V0. Okay. And this I value which is also less than IS. IS the short circuit current na. Basically IS is equal to what? Tell me now. Short circuit current is V0 by RTH. But here what is the I value? Tell me now. This is V0 by, that is RTH plus R na. So this I value less than ISC definitely, isn't it? So that's why, what's the option? You see this thing, option B. Okay. Next one. The figure shows an accurate equivalent circuit of the PV cell. For this cell, this is a PV cell they given. What is this thing here for this cell? I think problem is not clear properly. We'll do it. In a pure resistive circuit, the average power factor, pure resistive circuit, average P average. What the P average? You tell me now. P average power, which will be equal to what? Tell me. VRMS IRMS into cos pi. Cos pi is 1 na? So which will be equal to V naught by root 2 I naught by root 2. So that should be equal to 1 by 2 into V naught I naught. Yes, 1 half of the peak power. Yes, 135. 1 half of the peak power. Next. Four parallel resistors connected in parallel with 5 resistors are connected to a DC supply of 210 volts. If R is a resistance of each resistor and supply current is 5, the value of R is. What are they given? 4 resistors connected in parallel with 5 resistors are connected to a DC supply. What you have? 4 resistors or 5 resistors first of all? Fine. Okay, leave it now here. So this thing, yeah, that's it for today. So that means any other queries and all you can ask me. Yeah, this complete PDF will be distributed to all of you. The PDF will be also distributed to all of you. Do like the session and comment in the comment section. So I will share this PDF also. The PDF will be shared to all of you. Do like the session and share to all your friends. Like the session, everybody. Yes. So I think something is happened. I think so. We'll rectify it. Right. Chalo.